So under supervised learning, mainly it is used for the prediction technique. So for example, you see in the supervised learning, we are using the classification problem. So see example, various animals are given and what it is given in supervising, it is used for the prediction. So initially we are providing the training process and supervised learning. What are the images we are going to recognize, that will be given as the training part, and from that we will go to the testing part where it predicts the image correctly. Okay. But in the unsupervised algorithm, we are not going to train any system. The various inputs will be given to supervised, and by means of the system, group the systems. Okay, the similar images will be, similar features containing the images will be grouped together under unsupervised algorithm. Therefore, under supervised algorithm, we are going for the classification part, and under unsupervised algorithm, we are going for the clustering part, which groups similar types. So the supervised learning means, from this what we can understand, it is considered to be the predictive model. So which can be created based on what the input set of records, what we are going to give to the inputs with respect to output data. Under unsupervised, the patterns and various structures are found in data and it is labeled appropriately. Okay. So under types of machine learning, if suppose the input, we will see what are the various features are there under these types of machine learning algorithms. So while considering the input data, under supervised learning uses known and labeled data as input. That means what? Already known data and labeled data are used as the input. But under unsupervised learning, we are not going to train anything. Therefore, it uses unknown data as input. Okay. So since here we are using a large amount of data both under testing and training, the computational complexity is considered to be very complex. So while compared to supervised learning, the unsupervised learning here it is considered to be less computational complexity. Okay. So in real time, while we are using it, in the supervised learning, it will be using of observation analysis. Unsupervised, it will be using of real time analysis of data. So the number of classes under unsupervised learning, we are not aware of the number of classes. And the accuracy of the results will be more under supervised learning, because only depending upon the results, what is in our need, that will be given as the input. So here the accurate and reliability will be more while compared to unsupervised. Under unsupervised, it will be developing a moderate, accurate and reliable results. So the machine learning, mainly it is divided into two major types. One is supervised and unsupervised. Under supervised, it is divided into classification and regression. So under classification, it will produce the results accurately, that is yes or no, discrete values under classification. So here we will be using the concepts of the support vector machine, the discriminant analysis, the naive Bayes theorem and analysis, and the nearest neighbor algorithm. Under regression, it will be producing a continuous results. So here we are using an algorithm of linear regression. The method is a method decision trees are neural network. While coming unsupervised, we will be studying about the clustering technique. So under in order to group the images, we will be using the algorithms of k-means clustering, k-means algorithm, Gaussian
My voice not audible, ma'am. Ma'am, my voice not audible, ma'am. Ma'am, woman voice not audible, ma'am.
Excuse me, ma'am. Voice கேட்கல
Sir,
ma'am.
sir, sir,
Ma'am,
அதுதான் report பண்ணிட்டு இருக்கேன்.
voice reach ஆகல
Wait,
ma'am.
sir. Yes, sir, yes.
Hello,
Ma'am, now it's okay.
whether audible, ma'am?
Yes, ma'am. Now it is audible.
Okay, okay, ma'am.
Ah,
Okay ma'am, இப்போ audible ma'am.
yes, ma'am.
Okay, no. So whether to start from which slide, ma'am? Shall we start from this? Hello, whether it is audible?
Yes, ma'am. Audible, ma'am. You continue, ma'am.
Okay. Okay, so while considering the algorithms under machine learning, it will be dealing with the supervised learning and unsupervised. So while dealing with this we have seen in the previous slide, under supervised learning, we will be going for the classification and regression part. So under classification, mainly it is used for detecting the identification of the fraud and for image classifications, and in order to return to the customer, that is the customer retention, and in order to have various diagnostic process under medical images. Okay. So while considering under regression, we will be going for various types of applications such as the prediction of the population growth and the estimation of the life expectancy and what is the market forecasting, weather forecasting, etc. Okay. So while considering unsupervised learning, we will be going for the dimensionality reduction and clustering part. So under dimensionality reduction, we will be going, it deals with the big data part, that is the big data visualization, various compression techniques, and the feature elicitation will be done under this dimensionality reduction. And under unsupervised also will be going for the clustering part, where under clustering we will be segmenting the customer depending upon the customer needs, and then it is used for the targeted marketing and various recommender systems. Okay. So yeah, apart from the supervised and unsupervised, we are also using reinforcement learning techniques by using this machine learning. So the various applications for this reinforcement learning are the various robotic actions, robotic navigations will be done only by means of this reinforcement learning, and various gamings and real-time decisions will be based upon this reinforcement learning. Okay. So this we have seen previously under supervised learning. See, the system is learning, that is, it is trained by means of what are the useful messages are there. That is, it is not considered, it is considered to be not spam. And if suppose any unnecessary messages are there, it is considered to be spam. And these both messages are trained under this learning system. And then it is given to the supervised learning, that is the neural network, and it separates, it categorizes into the useful messages and not useful messages, that is spam and not spam. Okay, so here already we have trained the system and it is inserted into the neural network. So when a new mail enters into the trained network, it categorizes into either useful message or not useful message. So what does it do? It enables the machine to be trained to classify the observations. So it is used for the classification process. Okay. So under unsupervised learning, various inputs are given, and what the system does, it will group the similar messages into a single group, and what are the similar messages are there, that will be grouped under this unsupervised algorithm. So that is grouped by means of clustering algorithms. Okay. So under reinforcement algorithm, what it does, it will be maximizing the awards, and it will be minimizing the errors. So see here, it is considered to be an agent, and he is choosing the environment. One is warm and another one is cold. So by unknowingly, he moves towards the warm environment, and it is considered to be bad. So next time he is avoiding it and he is changing his environment. That is considered to be the reinforcement. That is what he is doing. He is maximizing the rewards and he is minimizing the error. Therefore, the actions are what? First, he is observing both system. He is selecting the actions using some policies. Then he is doing the action. After doing the action, he is getting the rewards or penalty. So since he is going to the home environment, he is receiving the penalty. So what should be the next step? She should update the policy. So he is updating his learning step, and finally he is iterating the system until the optimal policy is reached. This is an example for reinforcement learning. And the next one is considered to be the name-based classifier. It is considered to be one of the probability model. So here, for example, you see there are two persons are there. So if suppose any third party or any we are assuming any anonymous email is received, then we will be looking out what are the words are received from that anonymous mail, and we will be checking out whether that particular word is often used by which person. Okay, so depending upon that, the probability score raises, and depending upon the probability score, we may assume and we may achieve the result, and we may guess who is the sender. Okay, see here, a particular sender sends this kind of messages, and another particular sender, while he is sending the message, this all are the often used words by him. So if suppose we are receiving an anonymous mail with this sentence, then we will look it out. Most probable words are received by which person, and then we can guess who is the sender. Okay. So in order to have that, we are having the probability values. So if three words are here, what may be the probability of occurring in a particular sentence? Similarly, this person has this kind of words, and in that particular sentence, if this words occurs, what is the probability of occurring this kind of words? And who is having the maximum probability score? You can guess that may be the anonymous sender. Okay. So the event with what are the various powerful techniques used in this name-based classifier are, we are predicting it real time, and then we can classify the text classification, and also we can filter the unwanted messages, that is a spam filtering. And if suppose we want to recommend any kinds of system, that also may be processed by means of this name-based classifier. Okay. And the next one is considered to be the support vector machine. So the support vector machine is a discriminative classifier. So here under this the support vector machine, we will be using a hyperplane such that we can group and we can divide into two or many groups depending upon our needs. Okay, see here, suppose we want to plot two classes, and given in the graph you see we want to separate this group and this group separately. Therefore, we are achieving it by means of introducing a line, or it is also known as a hyperplane. So if suppose we are using only the two planes, that is x and y, then we can use a straight line, that is a line. If suppose we are using the multi-dimensional space, either x, y and z, then we can use a hyperplane in order to separate out these classes. For example, you consider this is why we are going for hyperplane. We are having two planes x and y, and here we are having some similar group of elements, and here we are having some similar group of elements. So if suppose we are having only x and y axis, and if suppose we are separating it in a line, then we cannot do this separation. So in order to avoid that, just we are using the multi-dimensional, that is instead of xy, we are using xyz plane, and we are plotting towards zy axis. And after plotting zy axis, see here we have grouped the groups similar into two types. One is here and another one is here. So it is xy, and we are rotating it towards zy, and hence we can group together. So after forming this xz, now we are transforming this plane into zy into xy such that this will be formed as a circle, and this is grouped inside and this is grouped outside. Okay. See here, if suppose we are having more complex plane, more complex objects situated like this, then we are using a plane like this. We are using a line like this, such that we are separating it towards. See here, it can, if suppose we are using a straight line, so these two objects will be combined to this another group of objects. So in order to avoid this, we are using a complex line, such that, see here we are using a line, then we will be rotating and transforming the planes in order to form a straight line. Then again we are rotating and transforming in order to form the next linear line. Okay, such that we are separating the two groups, which is done by the support vector machine. And the next one is considered to be the decision tree. This already we have seen in the morning session. This is also considered to be one of the most important machine learning algorithm. So here what this does is it similarly mimics the human level thinking, such that it is easy to understand the data and make the good interpretations. Okay, so when we are using this decision tree, we will be also using a simple logic for the data to interpret. Okay, here it is also used for both classifications and regressions. For example, you see, this is considered to be a simple example. So if suppose we are using here, it is considered, the age is considered to be the numerical data, and this is considered to be the categorical data, whether he is whether the particular people is a family people or a sports people, or whether his class is considered to be what. So from this we are concluding that if the age is considered to be less than 7.5, then the class is considered to be high, and if the age is considered to be 27 greater than or equal to 27.5 years, and if suppose the car type is considered to be sports, then also the class is considered to be high. And if suppose the age is considered to be greater than or equal to 27.5, and if the car type is not equal to sports, then the class is considered to be high. Okay, so depending upon this, we are forming the decision tree. So if suppose we are forming the decision tree without having this, we can conclude from this itself. Okay, see, if it is 27.5 years, then it is high. Otherwise, if it belongs to sports and if it is 27.5, then it is high, otherwise it is low. So without having this table like results and without having this kind of equations, only from the decision tree we can directly conclude the results. Okay, so this is considered to be one of the type of application by using the decision tree algorithm. Then the next one is considered to be the k nearest neighbor. So under this k nearest neighbor, it is also a supervised machine learning algorithm. So supervised machine learning algorithm means here also the target will be known. Okay. So here it is also used for both the classification and regression techniques. So it is considered to be a lazy algorithm since it doesn't have any training step. Okay. At the time of prediction itself, we will be knowing all the types of points. So here the prediction step is considered to be costly. So while we are moving to the nearest neighborhood, and if suppose we want to find out our neighbors, then what we will do for the first step is we have to start to socialize with our neighbors. And the next step is after socializing with our neighbors, we will be able to pick the neighbors that matches our thinking, our interest and hobbies. And after, so therefore here while we are considering the KNN algorithm, these three are considered to be the features for our application. What are they? Thinking, interest and hobby, while we are considering what? While we are matching our neighborhoods. Okay. So see here how so it is similar to the KNN, how it works. See here. So what is this? What is this KNN? It is considered to be the number of neighbors who is going to join with us. That is considered to be the K value. So if suppose we are grouping this K value together, grouping the values which are nearest to K, then we can group with our results. Okay. So for a high value of K, we see that this score will drop, the F1 score will drop. Therefore, the test set reaches what? It reaches a minimum rate when the value of K is considered to be high. So how does this KNN algorithm works? First, we are choosing the value of neighbors who all are we are going to join. So most probably it should be an odd number. Then we are finding the distance of the new point to each of this training data. And after that, we are finding the k nearest neighbors to the new data point. And for classification, we are counting the number of data points in each category. then a new data point will belong to that class that has the most neighbors. Okay. So for regression, the value of new data point will be what? Will be calculated depending upon the average of the k neighbors. For example, you see here the k is considered to be 5. So if suppose a new point is there here, by knowing the age and experience, they are going to predict the salary of the point, particular people. See, if suppose the age is considered to be 40, and if suppose his experience in months is in between zero point 0.2 to 0.4 na, then what they will be predicting a salary. So if suppose we want to predict, we are introducing a new point that is in between the ages in between 40 to 45 and the experience is zero point 0.6. Now if we want to predict the salary for this particular person, then what they are doing, we are finding out the shortest distance from this. That is, we are finding out the neighbors of this new data point. See here, this all are considered to be in the inside the circle. The various five people are there, and those all are considered to be the nearest neighbors. Hence, k is considered to be 5. So now what we have to do? We have to pick out the salaries of these five people, and then you average out the salary of those five people, and that will be the predicted salary for this particular new person. Okay. So this is an application under K nearest neighbor. The next one we will see about the deep learning, which is a subset of machine learning. So here it is concerned with the algorithms which is inspired by the structure and functions of the brain, that is called the artificial neural networks. So the artificial neural network means what? It mimics the behaviors and characters of our brain cell, that is called the neuron. So it uses the concept of artificial neural network, which consists of a layers of neurons, or it is also known as the computational units, to receive the input, and it applies an activation function along with the threshold in order to produce the output. Okay. See here, this is the just the note of the machine learning and deep learning. Here the input is given, the feature is extracted, and it is given to the classification problem, that is the neural machine learning algorithm, and we are finding the output. But under deep learning, we are giving the input to the deep learning, where under the deep learning network itself, it produces, it does both the problems of the extraction of features and the classification, and finally it produces the output. Okay. Therefore, that we have seen in the morning class itself, AI and artificial intelligence, it is a machine learning is a subset of this. AI and deep learning is considered to be the subset of machine learning, and both this deep learning and machine learning comes under AI. So the deep learning, what is the difference between machine learning and deep learning? The deep learning, machine learning, most probably it will be having a single layer. Under deep learning, we will be having more than a single layer, where the first layer is considered to be the input, followed by the hidden layer, and lastly will be producing an output. So here the hidden layers, it depends upon the optimization. We may have more than a single hidden layers. Okay. So see here how we are recognizing the particular shapes. Therefore, in order to have the shapes, first we will be training the system. If it is a square, now we have to check whether all the lines are connected and closed, and whether the all lines are connected to be perpendicular. So whether all four are, whether we have four lines, and whether all are connected and closed, whether it is perpendicular. So these three are considered to be the conditions, and these conditions will be trained into the system such that if it is tested, then it will display the results as square. Okay. So for example, you see this also we have seen there, we are having a group of animals and we have to recognize whether it is a cat or dog. So if it is cat, now what we have seen in the morning class, we have seen whether it will be having whiskers and some three conditions. So if those three features are satisfied, then it will be cat. Otherwise, if the features of dogs are satisfied, then it is considered, and then it will produce the correct output. Now, for here, the features of each and every animal is given here, and this feature will be given as input to this input layer, and it will be calculated, it will be trained, it will be tested in the algorithms, and if it matches the output, the corresponding output will be displayed. See, so under deep learning, we have seen that the next one is an artificial neural network. And what is this? Deep learning is considered to be what it structures the algorithm to create an artificial neural network that can learn and make the intelligent decisions on its own. Again, it is considered to be a subset of machine learning in artificial intelligence. Okay, so then it will be having the networks capable of learning unsupervised from data. The data may be either unstructured or unlabeled. Okay, so now we will see about what is this biological neuron and how it is interrelated and interpreted with the mathematical model. See, it is considered to be a biological neuron. So this is considered to be the nucleus, and this is whole is considered to be the cell body, and this is dendrites, and this is the axon which carries away from the cell body, and it goes to the another axon terminus, and it which in turn related to the neurons. See, so this cell body is considered to be a cell body in our artificial neural network, where we will be using the summation and the activation functions, and then this all are considered to be the various dendrites, that is the weight value, product of the weight value and the given input value. So here we will be setting the synapse, that is considered to be the bias value. So this summations will be given as input to the cell body, and after the summation of this by using the threshold, we will be setting the activation function. The output is produced under this output axon. So how we are converting this biological to artificial neuron? The structure of each node in the biological neuron is considered to be an activation function under this artificial neuron, and the structure of the network is considered to be the architecture in the artificial neuron, and the weights on each of the connections from the biological neuron is converted into the artificial neural networks. Okay. So while we are building up the artificial neural network, we have to consider these functions. One is the structure of node, and another one is the structure of the network and the weight of each of the connections. See here, this is the input value, and the constant bias value is set, that is x naught. So for all this, we are assigning the weight values W0, W1 and W2. So the input of this activation function is the summation of x0 w0 plus x1 w1 plus x2 into w2, and that summation will be given to this activation model. So here we will be setting up a threshold, and we will be by means of an activation function we will be producing the output. So the various activation functions are the linear function, sigmoidal function, tan function, rectified linear unit function, and softmax functions. Okay. So under this neuron model, we are using the firing rules. One is threshold rule, and another one is considered to be the perceptron rule. So under this threshold rule, the main use of this threshold rule is first it calculates the weighted average input, and then it gives the output it fires if the threshold is larger. Okay, if the threshold is found to be less, then the system will not work. Okay, and the next one is perceptron rule. Under this perceptron rule, we will be calculating the weighted average, and the output activation level will be like this. That is, the output is equal to 1 if the given function is greater than half, and if the output of a particular value is the same value if it lies between 0 and half. Here the half is considered to be the threshold. Okay, so the output will be disabled, that is 0, if the assigned value is considered to be less than 0. So while we are using the firing rules, the various activation functions are, one is considered to be the sigmoidal function. So under the sigmoidal function, we will be using either hyperbolic tangent function or logistic activation function. So if we are using the hyperbolic tangent function, then the function will be equal to 1 minus e power minus v by 1 plus e power minus v. If suppose we are using the logistical activation function, it will be calculated as 1 by 1 plus e power minus v. So mostly we will be using this logistic activation functions, or we will also use the rectified linear unit functions. So while considering the taxonomy of the neural network, there are two phases in neural information processing. One is considered to be the learning phase, and another one is considered to be the retrieving phase. So under learning phase, a training data set is used to determine the weighted parameters which defines the neural model. And under retrieving phase, it processes real test patterns and yield classification results. So learning phase, we will be determining the weight values. Retrieving phase, we will be testing the patterns and we will have the classification results. So this we have seen in the morning class, that is the supervised learning network. So it is used for the pattern recognition, that is the classification, and for function approximation, that is the regression. Therefore, it is applicable to the sequential data, that is either for speech recognition or gesture recognition, where we will be having the continuous flow of data. And under unsupervised learning algorithm, for a given data and the cost function to minimize, we'll be using any kind of function in order to produce the network output. Mainly here the unsupervised learning algorithm is used for the estimation problems. So the various applications under this estimation problems are: one is clustering, and we will be using the estimation of statistical distribution, compression, filtering, etc. So the multi-layer perceptron is this. So normally the multi-layer perceptron is considered to be a feed-forward artificial neural network. That means it will give the input to the input layer, then it is processed under the hidden layer, then it produces the output layer only in the forward direction from input to output. So under artificial neural network, see here we are given an example, that is here a model is set up in order to develop an XOR problem. So see, these three are considered to be the inputs under XOR, that is three inputs are there. So when it will raise the input as 1, if any two inputs are considered to be high, then the output also will be high. Otherwise the output is 0. Okay. So see here, this is our developed model. So the three inputs are given, x1, x2 and x3. And after that we are setting the weight value to be 0.3 and we are setting the threshold to be 0.4. Okay. So for example, you see, if suppose we are giving the value to be all the values to be 1, then the output is to be 1. Therefore, 0.3 into x1 plus 0.3 into x2 plus 0.3 into x3 minus the bias value, the threshold value is set to be 0.4. Therefore, if all the values are 1, what we will get? 0.3 into 1 is 0.3, then 0.3 into 1 is 0.3, then here again it is 0.3 into 1 is 0.3. Therefore, what we will get? We will be getting 0.9. So 0.9 minus 0.4 is what? 0.5. So the 0.5 value is considered to be greater. Therefore, we will be getting the answer to be 1. That is, if Z is true, the answer is 1. Otherwise, the results will be 0. That is, if you are getting any negative result, then the result will be less than 0 and hence we will be getting a 0 value. Okay, so this is the developed artificial neural network model for the problem of what? XOR gate. So what we have developed, the three inputs are there. We have developed a model such that its weight value is assigned to be 0.3 and its bias value, threshold value is set to be 0.4. Therefore, the perceptron, the generalized perceptron model is what? Y is equal to the function of summation of weight value into the input value minus the threshold value. So here an indication, or it is also known as the sign. So the general structure of artificial neural network is what we are having: various number of nodes depending upon the input features under the input layer. Then each node is connected to the all other nodes in the hidden layer. Then it produces a single output. Okay. So here, see here, it is the input. So here under neuron we will be having the sign value, the activation function, and the output produces the output. Therefore, the artificial neural network means what? It learns the weights of each and every neuron. Okay, so the algorithm is what? First we are initializing the weight value and then we are adjusting the weight value in such a way that the output of the neural network model is consistent with the class labels of the training samples. Okay, so the objective function will be what? The objective function will be calculating the error value. So the error is equal to what? The actual the desired output minus the actual output square. Okay, that is the root mean square value. So our objective is what? this root mean square value, error value should be minimized. And if suppose, that means what, we are comparing the desired output with the actual output. If the error is more, then again what we have to do, we have to update this weight value and again we have to retrain the model. Okay. So this is the forward propagation. Just we are propagating forwards from the input layer to the hidden layer and from the hidden layer to the output layer. So we will be having the bias nodes and then we will be calculating the process from input to output. So for each neuron, we will be calculating the weighted average of input and then the activation functions. Okay. So the activation function here we are using what, the logistical function, that is 1 by 1 plus e power minus b. So how we are doing the classification by back propagation. So the back propagation is considered to be a most probable used learning algorithm, that is a neural network learning algorithm. So where the neural network means what, it is connected, it is consists of a set of connected input output units where each connection has a weight associated it. Okay. So we are having two phases. Under learning phase, the network learns by adjusting the weight such that it will be able to predict the correct class label of the input tuples. Okay. And after that, it iteratively processes the set of training tuples in order to get the actual known target value. So for each and every training tuple, the weights are modified. So why we are modifying the weights? In order to minimize the root mean square error value. So how we have to minimize the square error? After producing the output, we are comparing it. If suppose the error is more, again we are traveling backwards from the output to the input through changing the weight values, and again the process is repeated. See, initializing the weight value, we are presenting the pattern, that is the input and the target output, and then we are comparing the output of the target output and the actual output. If the error is considered to be more, then we are updating the weight value. So the weight is updated by means of the Widow-Hawkes rule, that is a new weight is equal to old weight plus a small change in weight value. See here, this is the weight updation which is done by means of Widow-Hawkes, or it is also known as delta rule. A new change in weight is equal to what? The original weight value, previous weight value plus a small change in weight value. So how to find out the small change in weight value? It is considered to be the product of the learning rate, the error value of a particular input. Okay. See, normally this eta is considered to be the learning rate which lies in between 0 and 1. So typically we will be setting it to be the value 0.1, and D is considered to be the error signal of a particular input. So that is calculated by means of the desired output minus the actual output. So this is the role of neural network, how to calculate the value of input, the output, and the by means of an activation function. Okay. So how it can be applied? For example, you consider a motivational task of this is we are converting the perception into some kind of concepts. Okay. So how we are creating an algorithm for this? First, we have to understand the scenes, and also we have to describe this scene by means of a natural language. Okay. So in order to develop that, first we have to infer the various semantic concepts, that is the meaning of the concept, in order to allow the machines to interact with the humans using these kinds of concepts. So what we will do, first we will see the pixel intensities under this image. Then this is converted into an objects in an image. Then how it gets interacted, that should be represented, and finally we will be going for the scene description. Therefore, if this image is given as input, each and every pixel is represented here. That is considered to be the raw input vector representation, and this is converted into a slightly high level image representation, and like that it will go into level by level, and finally it is converted into the very high level representation, that is the scene description. Therefore, an image is converted into what? A natural language. So what are the various challenges in modeling this complex behavior is, there are too many concepts to learn. One is what are the various object categories are there. Therefore, many object categories are there, and also there are many ways of interaction in between these object categories. So the behavior is what we are. It is considered to be a highly varying function underlying factor. So the function such that it maps the low dimensional lattice factor space into a high dimensional observable space. So see, we are learning the configuration space of the robotic arms. So these all are the various actions of the robotic arms which is already trained in our neural network. So if a new input is given to this trained algorithm, then it will recognize this particular action into the trained, and that movement will be produced as the output. So how we are training? First we are converting each and every pixels, then it is converted into edges, which in turn it is converted into contours, and after combining this it is developed as an object part. Then we are categorizing those objects. That means what we are converting the local features into global features. So in order to train the layers one by one for this each and every categories, we are going to the strategy of greedy strategy. Okay. See here, back propagation, what we are doing. Initially, what we will do, the input is given here and it is processed in the hidden layers and the output is developed. After the output is developed, it is compared with the desired output. So if we are getting any errors, what we have to do again, if the error signal is back propagated here, and again we are changing the weight value and we are again remodifying the process and getting the results. So this process gets repeated by updating the weight value until we are getting a minimized error rate. So the drawback of this backpropagation neural network is what it needs a substantial amount of data, and also it leads to what a poor local minima problem. So a solution to this is in order to have a good solution, we have to go for the quicker convergence. Okay. So we are using the weights of the pre-trained network as the initial point. So the pre-training, we have to fast the process of pre-training such that the fine-tuning can be made slow. Okay. So hence we are going for the multitask learning. So these 4 images are given as input, and so we are using the learning task such that it separates out the images and here it produces the target. It groups out the humans and other people, animals and humans. Okay. So the objective for learning this is it has the ability to learn the complex and highly varying functions, and also it has the ability to learn the multiple level of abstractions. We can use here a large set of examples and also an unsupervised and semi-supervised data, and also it is used for the fast prediction and multitask learning. Okay. See here many images are given and we are comparing it. See either here it is a labradoodle and it is considered to be a fried chicken. We are comparing both these two features. See by observation both are considered to be somewhat similar. Only by categorizing this by means of some important features we can classify this both two figures. Similarly, see here both are considered to be similar. This is a puppy and this is a bagel. See both are similar. So only by having some kind of an important features extracted from this we can develop our machine learning model. See this is a sheepdog and this is a mob. More or less both are similar. Only by means of this eyes and mouth we can categorize these. Therefore this will be considered to be the important features. Similarly, this is a cupcake and this is a dog. We have to compare the features of both these two and then we have to analyze the results. So this is an owl and this is an apple. See how they are comparing. This is a parrot and this is considered to be the plant fruit. So the traditional recognition approach is what an input data is given. Then we are representing the various features of this particular data and we are using the learning algorithm in order to produce the output. See, an input image is given. So the low level vision features are extracted from this. That is the shift transformations are used, the edges are found out, and after this there are detecting an object and classifying it by means of a support vector mission. This is considered to be a traditional recognition approach. So next we are going for the convolutional neural network. So what is this convolutional neural network? It is considered to be a neural network with an convolutional operation. Okay. So normally we will be dividing in the whole image part into various pixels in the form of matrix representation. So after doing that, we will be doing the product of this matrix in at least one of the layers, and then we will be producing the output. But here, instead of doing the matrix multiplication in the whole process, we will be going for the convolution operation. So what does this convolution operation mean? If suppose we are having a large amount of pixels in a particular image, a particular group of pixels can be matrix pixel can be extracted from that, and then it can be mapped, processed and mapped into the final part that is considered to be the convolutional neural network. So in order to process this convolutional neural network, mainly we'll be going for the activation function of this rectified linear unit. So either it may be a sigmoidal function, or we will be having either zero value, or we will be going for the maximum value. See here, this is considered to be a typical convolutional neural network architecture. See, the input is given. So this input, we are extracting a particular feature. So this is whole feature maps are there. So this particular feature is considered to be the kernel. So this particular feature is extracted and it is subsampled here feature map. Then again it is extracted into the another layer. Like this, various subsamplings are there, and after completing process under all the subsamplings, we will be fully connecting the whole network in order to develop the output. See, this is the convolutional neural network. So it consists what in the previous step we have seen. It consists of various number of convolutional layers. So this all get interposed with the various activation functions. So here what we are getting 32, 32, 3. So this by means of this rectify linear unit and by means of this convolutional layer, it is subdivided such that we are getting extracting it as 6. Are you audible?
Yes, ma'am.
Okay. So this 32 cross 32 cross 3, it gets extracted such that it is converted by means of an applying subsampling of convolution layers such that it is using 6 5 cross 5 cross 3 filters. Okay. So again the 6 5 cross 5 cross 3 filters can be subsampled such that it can be subdivided into 10 5 cross 5 cross 6 filters. And finally we are producing the output. So here this process gets repeated until we are getting the final results. So whatever we are doing the process, the width of the layer remains same. See, the whole input is present like this. So this is considered to be what? 8 cross 8 matrix. So under this, we are subsampling it by considering a kernel space of 3 cross 3. So we are considering this 3 cross 3 matrix, and again it gets converged into a single value in the output. Similarly, it will be considering the next 3 cross 3, similarly next 3 cross 3, like that it completes all the process and produces the output. See, this is the main convolution operation. See what they are doing. This is the given input. So the input space is what? It consists of what? 4 cross 3. It consists of 3 cross 4 value. So here they are using the strides. So here the kernel is considered to be the value of this, that is 2 cross 2. So while producing the output, what does it do? First, it represents only this 2 cross 2. So this 2 cross 2 input gets product with this kernel. Therefore, what we will get AW plus BX plus EY plus FZ we are getting here. Then it will go to the next 2 cross 2, that is CB, GH along with the kernel WXYZ. Therefore, we will get the next value. See here ABEF, then the next one is B. This plane moves one position towards right. Therefore, we will get this square BCFG. Therefore, B into W plus C into X plus F into W plus G into Z we are getting here. Next, this plane moves one position towards the right. Therefore, we will get CDGH and we are getting the product of the kernel like this. Similarly, when it travels towards down, EFIJ. So EFIJ is then product with the kernel. Then it moves to here FGJH, then GHKM. Okay. So the process repeats until it completes all the process. So with this kernel, we are processing the whole inputs by means of various subsamples. So we are getting what 6 subsamples, and at the final step, we will be connecting all the subsamples in order to develop the output. So why the convolution is considered to be now more advantageous? Because first reason is it is a sparse connectivity. See here, if suppose we are using a normal process, each one gets connected to all of the nodes and the connection gets confused, and also the time complexity and the space complexity is considered to be more. So in order to avoid that, under convolutional neural network, the connection is considered to be sparse. See, this input is connected only to this nodes. Similarly, this too. Similarly, this like this, we are having only the sparse connections, and the dense connection is neglected. And the parameter sharing. Here, the parameter sharing is what it gets confused since each node is connected to all of the nodes in the next layer. So that also gets reduced under this convolutional neural network. And the next one is equivariant representations. Whenever the input changes, the output also changes in the same way in the convolutional neural network, unlike the other neural networks. So the convolution layers, see how we are selecting the kernel and how it gets subsampled. So see here, this is considered to be an image. So if this filter always extends the full depth of the input volume. If again we are subsampling this whole image, again it gets subsampled, but with the what? With the same depth of this filter. See, if there's 32 cross 32 cross 3 now, the same depth will also be used in the kernel. See, 5 cross 5, we are reducing it into 5 cross 5, but the depth is considered to be 3. Okay, therefore it converts the what? It converts the filter with the image, and it does the slide over the image spatially by using the multiplication value, that is the dot products. Okay. So see here, it is considered to be the whole image 32 cross 32 cross 3, and here we are developing a kernel that is a filter image 5 cross 5 cross 3. So this gets product with the whole image, like that the another sample, and all the subsamples get product, and finally we will be getting the output result. See the activation map, it slides over all the spatial locations. See what it does. First, we are doing this value 32, then we are using this 5 cross 5 cross 3, and by means of the sliding value, it gets converted into a first activation map of 28, 28, 1. Then we are using another mapping by means of 28, 28, 1. Like that, it continues up to 6 values. Okay, therefore, we can stack this up to 6 values in order to get a new image. So therefore, 6 samplings are done in order to get this original clear image. So in order to continue those convolution process, mainly we have to select the value of this strides. So how many strides we are moving? See, this is the strided convolution. This is the normal convolution, and we are downsampling it. How this downsampling is done? This downsampling is done by means of considering this strided convolution. For example, see, this is considered to be the whole image, and this is considered to be the filter. Now we are filtering, sliding over all spatial locations. See, this whole is considered to be what? A 7 cross 7 input spatial locations. We are assuming a 3 cross 3 filter. Therefore, first we are doing this. Then after, if the stride is 1, it moves to the next 3 cross 3.
Then if the stride is 1, again it moves to the next 3 cross 3, then again to the next one, and again to the next one, such that it has what? 5 process. See, first process 3 cross 3, 1, then the next 3 cross 3, 2, then the next 3 cross 3, 3, and the next one 4, next one 5. Therefore, it produces what? A 5 cross 5 output with the stride value what? The stride value is considered to be 1. So now you consider if the stride value is considered to be 2, therefore what? First 3 cross 3, then if the stride value is through, it goes here. It moves 2 positions to the right. Therefore, we are getting the second 3 cross 3, and if the stride value is 2, again we are getting what? The third 3 cross 3. Therefore, the stride is 2, and we are having the input as 7 cross 7. Then it produces an output what? 3 cross 3 output. So now suppose if the stride is 3, then we will see what will be the output. See here, first 3 cross 3, then we will get what? Next 3 cross 3, it moves and it gets here, and we will not have any values. Therefore, in order to map this, we cannot apply 3 cross 3 filter on this 7 cross 7 output in order to produce an output with stride 3. Okay. So we are developing it to be stride 1 and stride 2. So we can do manually like that, or how to find the output size? We can do the output size by the means of this. That is the total value n minus the f value divided by stride plus 1. Okay. So if the stride is 1 since we are using 3 cross 3, that is the f value. The total value is 7 cross 7, that is 7. Therefore, stride 1 applies 7 minus 3 by the stride plus 1, we are getting it to be 5. Okay. If the stride is 2, we are getting it to be 3. Therefore, while applying stride 1, we are getting the output to be 5 cross 5. While getting this applying stride 2, we are getting the value to be 3 cross 3. But while using the stride 3, what it does? One is this, then again it moves towards this, therefore we will get this, and for the next step we cannot move. Therefore, see here 7 minus 3 by 3 plus 1, we are getting only 2.33. So this will produce an error result. Therefore, for 7 cross 7, with the strides 1 and 2, we can produce the outputs. So if suppose we are using 7 cross 7, if only a particular value is used and other values remains unused, then we have, if it doesn't have any value, then we have to go for the step of 0 padding. Okay. See here, it is common to the border. If suppose any values are left blank, then we have to apply the values for that. See, in general, in convolution layer with the stride 1, it has the filters of size f cross f. And if suppose we are in need such that any value is not present, then we have to apply the 0 padding with the values what? F minus 1 by 2. So this will preserve the size to be spatial representation. See, an input volume is 32 cross 3. So if it is a stride 1 it has 10 5 cross 5 filters. If we are using the padding 2 then what is the formula? We are using this. That is the total value n. Then the padding value. Then we are separating it by stride plus 1. Okay. So how to choose the number of parameters? So the number of parameters in each value will be represented by depending upon this parameter filter representations. So from this, with the stride 1, we are getting this 5 cross 5, and their depth is what? Their depth is considered to be 3. Therefore 5 cross 3, it is considered to be what? 75 plus 1 stride value, that is the bias value is 1. Therefore, totally we will be getting what? 76 parameters in a particular layer. Since we are having 10 5 cross 5 filters, therefore 10 subsamplings. Therefore, the 10 multiplied with this 76, and the total number of parameters for the whole image is considered to be 760 parameters. So the summary of this convolution neural network is what? First, we are accepting the volume of the whole image, that is W1 into H1 into D1. and then we are representing the 4 hyperparameters. One is how many number of filters we are going to use and what is their spatial extent, how many strides we are going to apply, and what is the amount of padding. Okay, and then we are producing the next volume of the size W2 H2 D2. How we are applying, what is the value of how we are getting the value of W2, and how we are getting the value of H2 and D2, where this is considered to be the width and this is considered to be the height of the image, and D is considered to be the depth of the image. So by having this various subsamplings, we will reach out the clear image under each and every subsamplings, and finally by connecting all the subsamplings, we will get a cleared image from the original blurred image. Okay. See, accepting the value requires this 4 parameters. So for setting this number of filters, always the filters k will be represented in the form of cos of 2. For example, 2 power 5 or 2 power 6, like that it continues. So if f is equal to spatial extent, if we are getting it as 3 cross 3, then the striding value will be 1 and padding value will be 1. So if we are using 5 cross 5, then the striding value 1 and padding 2. So if it is we are using 5 cross 5 and the striding is 2 now, then we have to calculate depending upon their representations in the samples. We have to find out what is the fitting value of this 0 padding, and then we have to apply. Okay. So after this, we have to apply the process of pooling. So the pooling is what, instead of having a very large image, the large image is shrinked such that we can apply either the maximum pooling or the average pooling in order to reduce the total number of pixels such that the accuracy will be developed more. Okay, so we are applying a maximum pooling. Now see here, the 4 cross 4 is given here, and again it is divided into various 2 cross 2, such that this 4 cross 4 we are developing, the input is developed and it is produced as the, or reduced as the output as 2 cross 2. So if the maximum value pooling is applied for this in order to reduce this 4 cross 4 into 2 cross 2, now see, first under this 2 cross 2, the maximum pooling, maximum value is 20. So here the maximum value is 30. Here it is 112 and here it is 37. So that is replaced here. Maximum pooling, instead of this original 4 cross 4, it is reduced into 2 cross 2 by means of maximum. Otherwise, it can also be reduced into 2 cross 2 by means of an average pooling, where this all 4 values gets averaged and we are representing here, and this 4 gets averaged and it is represented like that. Similarly, we are replacing all the values of 2 cross 2, hence it is reduced. So this is considered to be what, a small translation of this a large output. A small translation is done by means of either maximum pooling or average pooling from a large set of input. So this is the pooling stages. So see here, it is a representation of the original image 224 cross 224 cross 64. So after applying the pooling, this gets reduced into 112 into 112 into 64. Okay. So what we are doing the down sampling in order to get a clear image. So if the blurred image is present and if it is expanded, again the noises and errors will be increased. So in order to reduce that, we are going for the downsampling of this pooling in order to have a clear image. See, an example is given for maximum pooling. This is a single depth slice is given, and here we are going to apply the maximum pooling with a stride 2. So stride 2 means we are considering this two values, therefore stride 2. Since it is 2 cross 2, we are considering this and this. Therefore, here the maximum value is 6. Here it is 8. Here it is 3 and 4. Hence, it is replaced with this value. So again, the summary is this what we have seen previously. Therefore, we have to note that it is not common to use 0 padding for the pooling base. Whatever the input values are given, we can apply the values. Okay. So now we will come, so that is the convolution neural network, how we can develop a cleared image from the blurred image. So under convolution, what we are doing first, we are developing the convolution layers by selecting the filters, that is the kernel layer. Then we are finding out the value of strides. So with the minimum number of strides, we have to choose the stride value such that how many subsamples can be developed, and after that we are applying the padding and we are applying the pooling, and after completing each and every feature map, we are completing it and we are connecting all the feature maps, that is all the subsamplings, in order to get the clear image. So if we are not getting any clear image, again we have to change the weight value, that is again we have to propagate backwards in order to achieve the clear value. So for examples, you see here under back propagation, how we are setting the model for this back propagation. Here we are developing a system such that f of x comma y comma z, the function of x, y, z is equal to x plus y into z. Okay, and they are given the value for x, y, and z. So if suppose we are having two functions, one is x plus y and another one is the product of these two functions. Therefore, initially we are assigning this x plus y function to a variable q, and then we are applying we are having the function as the product of this q and z. So while we are differentiating this value with respect to x, we will be getting the value 1. If suppose we are differentiating it with respect to y, we will get the value 1. Okay. Similarly, for this equation, if suppose we are differentiating with respect to q, we will get z. If we differentiate with respect to z, we'll have the value q. Okay. So here I need to calculate the value of this 2f function with respect to x, function with respect to y and z. So but we are here, what we are having? We are having the functions such as sub-functions are present. So in order to have the main functions, you see here, this is the developed model, that is, this is the given input minus x, y and z. So x and y gets summed and it gets product with the z in order to have the output. Okay. So while using these values, we will be getting the output as minus 12. So how the back propagation model works here, on how our neural network model is developed. See, first this is considered to be what it is considered to be the dou f with respect to f. See, this value is what we have to calculate, find out the function with respect to z. So in order to have the function with respect to z, what we are having, you see, dou f by dou z is what? Dou f by dou z is considered to be q. So
Q.
what is the, it is considered to be q, see. So that is dou f by dou z. So x plus y is what? 5 plus minus 2. This value is considered to be dou f by dou z, that is q, that is it is substituted with the value 3. Then we have to calculate the value of this, that is dou f by dou q. So the function with respect to q, it is what it is given as z. So this value is what it is considered to be minus 4. Then we are calculating this value, that is the function with respect to y. So the function with respect to y, it is not given. So we are correlating the values with respect to this function with respect to y. So since we are having this value function with respect to q and function with respect to y of this q, we are just taking the product of this. So while we are taking the product of this, we are getting the value to be minus 4. Similarly, in order to have the function with respect to x, we are not having the direct value. Hence, we are subdividing into the function with respect to q and q with respect to x. Therefore, dou f by dou q is what? It is considered to be z. Z is minus 4. And dou q by dou x is what? Dou q by dou x is 1. Therefore, minus 4 into 1 is considered to be minus 4. So just like that, we are calculating all these values and we are representing the function and we are developing the exact output. So while doing the activations, first we have to calculate this all local variance such that the final output can be reached. Okay. See, dou L by dou x with respect to the function x. Therefore, instead of having, if suppose we are not having the actual functions, we have to correlate with the functions what is in present. Similarly, for dou L by dou Y, we are as well corresponding it since we are having as the function as dou Z by dou Y. Therefore, how we are finding out the activation function? We are having the various products of this weight value and the input, and then we are summing up this value with the bias, and finally we are applying the activation function in order to develop the output taxon. Again, this may be the input nodes, and again it will be given to the hidden nodes, and again it process and it will be developed to the output nodes. So these all are the various activation functions we have seen. So this is the sigmoidal function most probably we'll be using. If suppose we are using the convolutional neural network, we will go for this rectified linear unit. Either the value will be 0, most probably we'll be using the maximum possible value. So the deep learning, it is also present each and every applications. If suppose we are using an internet and cloud, it can be used for the image classification, the speech recognition, the language translation, the language processing, the sentiment analysis and recommendation process. If suppose we are applying the deep learning under medicine and biology, it can be used to detect the cancer cells, and it can be also used to grade the diabetic ranges, and we can discover the various drugs. And if suppose it is related with the media and environment, it can be used under video searching, captioning and real-time translations. If suppose we are going for the security and defense part, if suppose we are applying this deep learning under DRDO, then in order to detect the various phases of the intruders, it can be applied. And under video surveillance techniques and various satellite imaginary pods, we can use this deep learning. And under automated machines, in order to detect the various pedestrian actions and for lane tracking, and in order to recognize the traffic signs, we can also use this deep learning techniques. Okay. So while combining this machine learning and deep learning, machine learning means what we have done, what we have seen. It will have the separate process of feature extraction and the detection process, but under deep learning, it is considered to be a new evolution of machine learning where both process will be done under the same part. Okay. Therefore, the most important difference between these two is considered to be the data dependency. That is, what is the performance as the data increases. See here, if suppose the amount of data increases, under deep learning, the performance gets increased. But under machine learning, in the older learning algorithms, what it does, if the amount of data increases, the performance stops up to a particular point such that the algorithm gets optimized. Okay. Therefore, from this, what we can conclude, the machine learning can work perfectly even on a small set of data, where the deep learning works only for a large set of data. And the hardware dependency, while related with the hardware, again the deep learning is highly dependent on the high-end machines, but the machine learning algorithm can work even on the low-end machines. Okay, this is because the deep learning algorithms, it mainly includes the graphical processing units also, where the graphical processing units are required as they perform a large amount of matrix product process. So these operations can be only done under this GPUs. Hence, the deep learning algorithms are highly dependent upon the high-end machines. So while considering the feature engineering, under feature engineering, what we are doing, we are using the domain knowledge from the expert system. So if suppose we are using this domain knowledge, we can reduce the mean complexity of the data such that the learning algorithms will make the patterns more visible. However, this process is also considered to be difficult and it is considered to be expensive. But in case of machine learning, most of the features, mainly it will be identified by the expert system, and then it will be programmed as per the domain type and the data type where we are going to use and what are the data we are going to use for our particular application. Therefore, the machine learning performance mainly depends upon how accurately we are identifying the features and extracting. If suppose we are accurately and correctly identified and extracted features, then our machine learning algorithm works very better and the performance will be more. And while we are solving any problems, What we are doing, we are recommending what? We are subdividing the main problem into various subpart and then we are solving them individually. It is applied to each and every relevant people and then finally we are combining them to get the final result. But under deep learning, it solves the problem only from end to end. Okay. See here. See, under machine learning and deep learning, it is considered to be a multiple object detection. Under machine learning, what it will do, each and every object is identified simultaneously, and then the result gets introduced. The result is developed as the output within a particular amount of time. But if suppose we are using the deep learning, we have to recognize each and every image individually, and then only it will be detecting the objects finally. Therefore, the time complexity is considered to be more. Hence, the machine learning approach we are dividing into two parts. One is first we are detecting the object and then we are recognizing the object. Okay. So, in order to detect the objects, we are having the bound box detection algorithm to scan each and every image and then it will be detecting them. And after detecting, you will be going for the recognition algorithm to recognize each and every objects. So while we are combining the results of this both algorithm, we will get the final result under this machine learning. Therefore, the machine learning is considered to be have a better approach in order to identify and recognize an object within a particular amount of time. But under deep learning, it gets the processor, what the processor will do, it will insert all the images into the algorithm and it will give out the location of each and every object and then it will produce the name of the object, which takes a large amount of time. Okay. Hence, see here the deep learning algorithms takes a lot of time to train. This is because for what? Since it works for a large image, the parameters are considered to be more in the deep learning and hence the training will be longer. But under machine learning, since we are subdividing it, the training time is also considered to be less while comparing it with the deep learning. Hence, the execution time is completely reversed when it comes under the testing of data. Because during testing, the deep learning algorithm, it takes what? Only a less amount of time. But the machine learning algorithm, since it has more subsamplings, it uses the k nearest neighbor testing time and it increases the data as the data size increases. So while we are interpreting, suppose we are using the deep learning, it automates the essay scoring, but the performance it gives an excellent and same as human beings. Even though the performance is excellent, it also produces some kind of disadvantages. That is, mathematically, it is possible to find out which nodes of deep neural network are activated at particular time. But we cannot find out what all the neurons are used for that particular model and what kinds of layers are collectively representing. So so here, since these are considered to be the disadvantage, here it is difficult to interpret the result. But in machine learning, since we are doing the subsampling, it is very easy and it gives an accurate result while we are combining all the models. Okay. So while considering the applications of deep learning, mainly it is used as a recommendation engine. So under recommendation engine, it uses both methods. One is the content-based method and another one is considered to be the collaborative method. So under content-based method, depending upon the contents, it gives the recommendation. See here, a lady buys this kind of product. So if she likes this, she buys. So by means of recommendation engine, this engine recommends another product similar to this kind. This is considered to be a content filtering. Under collaborative filtering, it will be finding out similar customers. If a lady buys this kind of product, it finds out who all are the persons are there who is liking the same product and he will be recommending. So this is considered to be a content and collaborating, where this application is considered to be an easier in order to predict what all the products she will buy. But here it is considered to be difficult to implement as we have to look out who all are the persons buying this. Okay. And also it also applied to the text sentimental analysis. So finding out the text sentimental words They are finding out what are the positive words, what are the negative words, and who all are using the positive words to how much percentage. Everything will be calculated by means of this text sentimental analysis. So in order to have this text sentimental analysis, we will go into the process of natural language processing and recurrent neural network. Then the chatbot also will be using this kind of technique where this chatbot is seen as many as the pillars of the next generation of the user interfaces. So it can be trained with some kinds of samples of dialogue and recurrent neural network like that, such that whenever we are asking for any queries, it can be the answers can be response can be displayed. Okay. See here, artificial intelligence is there. Both machine learning and deep learning techniques are inserted into this artificial intelligence, and it processes and it produces the outcomes of either it may be an NLP, or it may be used for the prediction analysis, or it may also be used under sentimental analysis. Okay. So this technique is also machine learning and deep learning is also used under recognition of images. So it can also be used under the marketing researchers, such that we are segmenting the market segmentation, then we are analyzing it, and further it can be improved by means of a deep learning technique. So in order to have this marketing research, we are in need of an enormous amount of data, where this enormous amount of data can be fetched from the big data. And the machine learning services can also be used by accessing data from the clouds. So unlike other cloud services, it also uses the platforms in order to have the models such as cognitive modeling, automated machine modeling, and machine learning model management, model serving, and GPU based computing. Okay. So while this is used under cloud, it can also access this various kinds of services such as vision service, the speech processing, the language processing, and automated machine learning for the developers. If suppose it is machine learning cloud is used for data scientists, then they can use under platforms for training, tuning, and serving. If the machine learning cloud is used for developing uh, operating systems, then it can be used under CPUs and GPUs for the infrastructure as a service. Okay. So by combining this machine learning in the cloud, it can also be used under the various services, the platform as a service, infrastructure as a service, and for the services under developer sites. See here, the object and scene, each object, each scene, and the activity is detected. See in the faces, this face is recognized, and here the facial analysis is recognized by seeing this mouth actions, what is whether what she is doing, is smiling, she's happy, and her eyes are open, and this is considered to be a female. This is also recognized, and what are the various pathing techniques are done under various playing tournaments, and they are also kind of detecting the various contents whether it is safe or unsafe. And if suppose a celebrity is there, how he is recognized. And if suppose any text is present in an image, what we have to do, what these kinds of words are there, and how it is recognized. So these all are the various applications and techniques used in order to have this machine learning. Okay. So what are the real day-to-day applications are there? We can apply this machine learning technique. Most probably recently we are using this convolutional neural network in order to have a better and accurate results. Okay. So morning we have seen about what? Morning we have seen about various techniques, the machine learning and its applications. And now we have seen what are the various techniques under this machine learning. Okay. So any queries for that?
Participants, if you have any queries, please ask. If no queries means we will conclude the session.
Mistake I have left. So if any queries are there,
No, ma'am.
Shall I get the feedback from the sessions of the morning session and afternoon session?
Shall we conclude the session?
Yes, ma'am.
Okay. So, first of all, I would like to thank Uma Maheshwari ma'am, Professor Department of Computer Science, BSNA College of Engineering and Technology for accepting our invitation to be a resource person for today's session for this AICT sponsored STDP program. Ma'am have given a valuable information in the topic of basics of machine learning, opportunities of machine learning, applications of machine learning, and how this machine learning is practices in various applications and types of machine learning. And then working of and ma'am have clearly explained working of machine learning algorithms and deep learning, neural and various techniques of neural networks like a polling technique and backpropagation, and also explained about the role of deep learning in various sectors like marketing research. Thank you, ma'am.
Thanks, ma'am.
And I thank all the participants to conduct this today's session in successful manner. And the feedback link for feedback is given in the chat box. And for tomorrow session, the topic is Introduction to MapReduce Framework and Hadoop Distributed File System. Tomorrow's resource person is Professor Kiran Kumar, Department of Computer Science and Engineering, New Horizon College of Engineering, Bangalore. So once again, I thank the resource person and all the participants for conducting this today's session in successful manner. I request the participants to give the feedback without fail. It will be the link will be given in chat box. Shall we end the session, ma'am?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, ma'am. Dear participants, don't forget to give the feedback, please.
Okay, ma'am.
Okay. Okay, thank you, one and all.
Thank you all,
Thank you,
and thank
ma'am.
you, ma'am.